Imagine looking up at the night sky, the stars twinkling in silence, unaware that high above, entire galaxies are slowly drifting toward one another, destined for a collision that will shake the very fabric of space. Two massive star systems, each holding hundreds of billions of suns, dance toward a union not of destruction but of rebirth. Their shapes twist and tear, their cores thrum with ancient power, and from the chaos, new stars are born in dazzling waves of light. These are not rare events. They are part of the universe's natural rhythm, a slow, majestic choreography of gravity and time. Across the cosmos, galaxies collide in a ballet that takes hundreds of millions of years to unfold, but the effects are profound and eternal. And soon, perhaps in 4 or 5 billion years, our own Milky Way may join that dance. It all began long ago, just after the universe was born in the Big Bang. In its infancy, the cosmos was filled with hot gas, rapidly expanding and cooling. Matter began to clump together under gravity's pull, forming the first stars and, in time, the first primitive galaxies. These early galaxies weren't the majestic spirals we admire today. They were chaotic clouds of stars, irregular in shape, constantly jostling and merging with their neighbors. These early collisions were frequent. Small galaxies would combine with slightly larger ones, slowly growing over time. The Milky Way itself was shaped by such events. Even now, it holds the remnants of galaxies it devoured in its youth, stellar streams and star clusters that are, quite literally, the bones of its past meals. One such victim, the Sagittarius dwarf galaxy, is currently being torn apart, its stars smeared across our galactic halo like a ghostly reminder of the Milky Way's hunger. As the universe matured, galaxies became larger and more complex. They began to take on the shapes we know today: spirals, ellipticals, barred spirals, each one a distinct fingerprint of its past interactions. And with more mass and more structure came more dramatic collisions. Today, we can see these grand events happening across the universe. Thanks to telescopes like Hubble and the James Webb Space Telescope, we are peering billions of light years into the past. And what we see is astonishing. Galaxies caught mid-embrace, their shapes stretched and shattered, their stars flung into space, their gas compressed into brilliant waves of starbirth. In the constellation Hercules, we find 3 galaxies tangled together, NGC 6745. This cosmic trio is a perfect example of the chaos that ensues when galaxies merge. Their once distinct forms are now a tangled mess, pulled apart by gravity, glowing with the heat of new stars being born from compressed gas. Further out in the universe's distant past, astronomers recently captured an extraordinary sight. 2 galaxies locked in a violent duel, each harboring a central black hole. One of them had already ignited a quasar, a black hole, so active it radiates light brighter than all the stars in its galaxy combined. The radiation from this quasar was so intense, it reached across to the other galaxy, stripping it of its gas and effectively cutting off its ability to form new stars. A galactic battle played out in silence and light. Closer to home, in a galaxy pair known as ARP-143, a collision triggered an explosion of star formation in a triangular shape, something rarely seen in the cosmos. The result is a structure that looks almost artificial, like a cosmic warning sign glowing in the dark. It's a reminder that when galaxies collide, they do more than break, they create. While all of this unfolds across space, the Milky Way quietly turns. From our vantage point, we see calm, but astronomers have known for decades that a storm is coming. Our galaxy and the nearby Andromeda galaxy are on a collision course. At 2.5 million light-years away, Andromeda may seem distant, but it's approaching at a speed of roughly 110 kilometers per second. Over the next few billion years, the distance will close. The shapes of both galaxies will warp and pull, their arms reaching like fingers toward one another. For a long time, scientists believed the collision was inevitable. But thanks to recent data from ESA's Gaia mission and observations from Hubble, we now know the story may be more nuanced. There's only about a 50% chance that the 2 galaxies will collide directly in the next 10 billion years. The rest of the time, they may just dance past one another, orbiting, interacting, reshaping, but never merging. Other players complicate the picture. The Large Magellanic Cloud, a smaller galaxy orbiting the Milky Way, is moving closer and could merge with us in just 2 billion years before Andromeda even arrives. It may dump enough gas into our galaxy's core to reawaken our dormant central black hole, triggering bursts of radiation and star formation. But if Andromeda and the Milky Way do collide, the result will be extraordinary. Stars will rarely hit each other directly, the distances between them are too vast. But their gravitational fields will interact, flinging stars into new orbits, triggering waves of compressed gas that will birth stars at furious rates. These waves will light up our skies with new suns, making the heavens unrecognizable. Over the course of several 100 million years, the two galaxies will begin to merge fully. Their shapes will lose definition, their spiral arms disintegrating. In the final stage, their central black holes will spiral toward one another, eventually combining into a single, massive gravitational monster. When that happens, it will send ripples, gravitational waves through the fabric of space-time itself. LIGO and future space-based observatories may one day detect such an event. When the dust settles, what remains will be an entirely new galaxy. Scientists have named this hypothetical future system Milkomeda, a hybrid of Milky Way and Andromeda. It will likely be an elliptical galaxy, more egg-shaped than spiral. Star formation will slow down as gas is consumed or blown away. The stars will grow older. The skies above, for any surviving observers, will be dominated by the warm glow of ancient stars and the quiet murmur of a galaxy that has finished its growing phase. And what of Earth? By the time this great collision unfolds, our sun will be nearing the end of its life. It will swell into a red giant, possibly engulfing Mercury, Venus, and maybe even Earth. Life, if it still exists, will have moved on or perished. But the galaxy will remember. The stars we see now will be part of a new pattern, a new map, shaped by a collision that was billions of years in the making. What's even more incredible is that this is not unique. Across the universe, hundreds of millions of galaxies are in the process of merging, orbiting one another, or preparing for collision. It is one of the main ways galaxies grow and evolve. Collisions are not rare or catastrophic, they are necessary. They trigger star formation, feed black holes, and help sculpt the diverse galactic shapes we observe today. And in the far, far future, trillions of years from now, these collisions will slow. The universe's expansion will carry distant galaxies out of sight, beyond our cosmic horizon. Only the descendants of the Milky Way and its neighbors will remain, forming one massive, dark galaxy drifting through a mostly empty void. But the echoes of these events will live on in the stars, the planets, and perhaps even the stories told by the life that may emerge. So, as the screen fades to black and the music swells, imagine a slow dance among stars, galaxies spiraling around each other, leaving trails of light in their wake. You have just witnessed one chapter of the universe's endless story, a story of gravity and light, of birth and transformation, told across billions of years and billions of light years. And there is still so much more to come. The universe is in motion. The next act in this cosmic ballet is already unfolding. So stay with us, because next time we'll travel into the cores of colliding black holes, or unravel the mysteries of galaxies so faint they have not even been named yet. If you enjoyed riding the spiral arms of the cosmos with us, don't forget to hit that like button. It helps us reach more curious minds like yours. Subscribe and turn on the notification bell so you never miss a trip through time, space, and the secrets of the universe.